Well, hey everyone, thanks for tuning into the DoD Contract Academy podcast this week. Today I'm with Bhaskar, and he is with DM3D Technology. Bhaskar, how are you doing today?
I'm doing great.
Thanks for joining, by the way. And, one of the things that we like to do is have companies on that are selling in different sectors to the government and just talk to them a little bit about their journey and how they've been doing it. And it's interesting for the audience to hear, practitioners in the art and just to hear, the good, the bad, and the ugly. So,
Sure.
but what I'd like to start off with is maybe a little bit about you. If you could tell me a little bit about yourself.
Yeah, sure. So I'm a metallurgist by background. That's my bachelor's, master's, PhD. Everything is on metallurgy and metal processing, and
Yeah.
I've been in this for like 30 years now. And so a long time to be dealing
Yeah.
with metals, but it's been fun. It's been fun. I love metals and metal processing, and currently, our company, what we do, additive manufacturing. So I've been in this additive manufacturing for about 20 years now.
Okay.
Yeah.
Excellent. So metallurgy, is that, I mean, I would assume that falls kind of under geology. Is that where you first started kind of learning about?
No, so it's like metallurgical engineering,
Oh,
so
okay.
now it's more called material science and engineering. But when we did our bachelor's back in those days in 80s, it was metallurgical engineering, fully focused on
Okay.
metals. And then slowly it evolved, and people started including like ceramics and polymers into this, so the subject is more called material science and engineering now, but it's
Okay.
metallurgical engineering. And the way metallurgy was defined in our days was making, shaping, and treating of metals, in three words, three simple words: making, shaping, and treating. So we start where the mining people leave. you know the geologists survey the ores in the earth, and then mining people digs it out and then hands
Right.
it over to us, and then we take it over from them, and then start extracting metals from the ores, and then eventually you shape them, like bar stock or round stock or forging or casting or extrusion, whatever, like usable forms.
Right. That's
Yeah.
really interesting. But what got you into that initially?
What got me into that? That is a long story.
Yeah.
When I was growing up as a child, like I had an uncle, and he was a mechanical engineer, and he always inspired me to go into engineering. He
Okay.
would give me like toys and things to build things, always
Right.
building things, and that's how I got into more mechanical engineering. And then eventually he was working, and then he switched into areas where there was a lot of overlap between metallurgy and mechanical engineering. So when I graduated from high school, he's like, metallurgy is a very nice place to be in at this time, so maybe you should look into that. And I'm like, okay, give it a try. So
Yeah.
that's kind of how I got into this, and it has been
Okay.
ever since my life.
And well, I can already tell you're highly intelligent. The only thing I knew about metals back in the 80s was Metallica. And as far as
Yeah, that is a different area.
that's definitely a different area, but it's all
That's
good.
exciting too.
Exactly. They're fun too. They're still going. They're still doing
Yeah.
great. Very cool. Okay, so you grew up with that and you kind of inspired in that area. And then you went to school for it. And when did you come to DM3D?
It's been so DM3D is a relatively newer company, started in 2013,
Hmm.
but it acquired an older company, POM Group. POM Group was formed in '99. It was like a sort of offshoot from University of Michigan. So that was early days of 3D printing and additive manufacturing area. So there's a professor, Jyoti Mazumdar from University of Michigan. So he had a patented technology, and POM Group was formed with that. And he recruited me to work for them back in 2004. So I
Okay.
started with POM Group in 2004. Now, you know, uh, POM Group remained like an R&D business. It did a lot of like federal contracts and
Sure.
advancing the technology and so on. But Jyoti, being a professor, his mindset was very much into R&D. He
Sure.
loved it, and he was a great guy. I mean, one of the phenomenal researchers we ever had here. But it was always R&D. So eventually in 2012, like the group then, which was funding it, kind of said, oh, we need to be more commercial. So
Sure.
that's when it kind of transitioned into DM3D technology. So it was a new group, DM3D, and the new investors, they wanted to focus it towards commercialization of the technology.
Okay.
And that's when I took over the company from Jyoti, and he kind of left the business and went back to university. So.
Okay. Interesting. So right now, what's your role in the business right now?
So I'm the president and chief operating officer of the company. Yeah.
Okay.
So overseeing the development and the growth and all of that.
Right. It's a hard job. Before we get into like the government contracting aspects of it, just because we have a lot of people in similar positions, on the business side that are listening here. I'm just curious, kind of, in the job that you have now running the business, what do you consider kind of the most challenging aspects of it and the most rewarding?
The challenging aspect is, so the additive manufacturing of metals, that's what we do. It's a relatively new technology. And the markets that we are working in is typically like space, aerospace, and defense.
Right.
Now, these are great areas and great fit for our technology. However, these critical applications have a very long qualification and certification lead time, which means, you demonstrate a product, but to get it to production takes a very, very, very long time. And that's a very difficult thing particularly for small businesses. It's one thing when General Electric Aviation, for example, they design a new engine, they work 10 years in advance. That's common for them, right? That's very common in space and aerospace. But for a small business, if you were in a new engine program and you have to wait for 10 years, that's a significant challenge. There's cash flow and all kinds of things that you have to handle. So
yeah, with all the certifications and approvals and all the spec, everything involved with aviation and without even introducing the government contracting process, which takes a long time.
That's correct. Yeah.
Just the approval process for, parts.
Technical approval process. Correct.
FAA. I'm like, all of that I would think are things that you have to.
It takes a long time. Yeah.
Okay. Interesting. But so you have a commercial line of revenue, but you're also selling to the government. Could we talk a little bit about that? It sounds like you had some government contracts in the original instantiation of the business back in the early 2000s. But, this one, and this is how I found you, I was researching in this area. We hadn't had any additive manufacturing companies on the podcast. And so I could see some government contracts that you've put together. Can you talk a little bit about how you entered the space and maybe what some of the first contracts, you don't have to go into too much detail, but kind of the first couple of things that you guys worked on?
Sure. So, like I said, POM Group, since it was more like R&D business, so started with R&D and advancing the technology, and we started with SBIR programs. So I think one of the first programs we had was a SBIR program with U.S. Army, developing new machines for this technology, and we developed, designed, built, demonstrated, and then installed finally the machine in Anniston Army Depot. That was during POM Group's time, and then several systems were built, including for U.S. Navy, and so we have like several systems in the DoD.
Look, your company can't afford to lose $2.3 million a year in revenue. That's the average that small businesses make selling to the government. And in this economy, when things are fluctuating, you want to have that stable income. So my clients through DoD Contract Academy are able to take our process and win government contracts without wasting time and money. Our system's focused, easy to manage, and customized for your business. You know, with the Academy, you're not alone. We have weekly coaching where we can get our eyes on your business. We can answer your questions. So you get the framework and you get to speak with us each week to make sure that you are successful. Now, I believe that this is the best platform that exists in the world for teaching small businesses how to sell to the government. I haven't seen anything like it. And the advice and guidance that we can provide to you and work with you to help you be successful, it's just simply unmatched. And at the price point that DoD Contract Academy is at, I think that it's at least worth giving it a shot, trying it out for a month. All you got to do to get started is join DoD Contract Academy. You go to dodcontract.com to do that. Watch our short, easy to follow training modules, and then put your system in place for winning government contracts. And you're going to work with our team to do that.
So that's how we kind of started it, and then that evolved into other programs. Right now, our major customer is NASA, for example, and a lot of it is still SBIRs, but SBIR 3s, where you are more in the commercialization phase. Not ones and twos, but more in the threes. So more mature level of the technology, and so that's currently we are doing several SBIRs with NASA, and then there are other programs also with NASA. Yeah,
it's interesting because, and then for those listening that don't know what SBIR is, Small Business Innovative Research program. It's great for businesses that have innovative technological solutions. The phase one that you mentioned, that's usually the first one you win. It's more of a low dollar technological feasibility study, maybe, but
yes.
What you're really trying to do there, right, is get a government sponsor, someone to sign a memorandum and sponsor you for phase two, right, which helps you to actually develop the solution. Now, what I find interesting, and right now, I mean, that could be between 1 and 1.9 million. I saw one for 1.9 million just a couple of days ago. It keeps going up each year. And of course, you could win multiple phase twos, and we've talked to people that have done that. What is interesting, though, about what you were saying is the phase three, right? Because a lot of people will refer to that as, the valley of death, getting between the phase two and the phase three. A lot of companies struggle to ever go beyond the phase two. Can you talk a little bit about that and maybe how you leveraged your SBIR experience and turned those into phase threes?
Yeah, it's all about, so phase three is exactly like you said. Phase one is basic level R&D, right? Just proving the concept. And then two is more proving the entire thing, like not just the feasibility, but demonstrating the whole concept. And three is the commercialization of that. So when you are actually making these machines, for example, some of the programs we built machines for US Army under commercialization program and demonstrated some of the earlier concept developed in phase two. So built parts and demonstrated that you can manufacture these parts to the quality needed using the phase three funding. It just simply allows you to work towards more real life components and things, that end user can actually use it. It's not just a demonstration, but a real piece of hardware or anything else, design concepts or whatever it is. But more ready for the end user to use it and test it out. So you could do even field testing under such commercialization programs.
Yeah. The SBIR program offers some benefits as far as being able to eliminate competition and sell directly. Were you able to take advantage of those, or?
We did some sole sourcing. Yes, we were able to do some sole sourcing because these solutions were developed specifically for the end user, by our company and our company alone. So yeah, if that justifies, then you can take advantage of sole source.
Okay.
But it has to be justified. It's not just because somebody likes somebody else, but it has to be properly justified that there's no other solution exists and things like that.
Yeah, it's one of the nice things about SBIR is there is language that allows for the sole source contract. And like you said, it has to be justified. However, without the SBIR, a sole source contract can be a lot harder for the government to award versus having a SBIR under your belt if that's the solution the government is looking for. So, no, that's great. And could we talk a little bit about maybe some of the other ways that you've sold to the government or contracting mechanisms? Have you guys ever been involved with subcontracting with larger businesses, or maybe competing on, one of the, like a NASA SOUP or GSA?
Yeah, so not GSA, but we have done, we work with defense quite a bit. So part of it is like directly some of the SBIR programs, but also for some of the prime contractors for government, like for DoD.
Right.
So there are multiple, like you will go to our website and see Huntington Ingalls, for example, BAE Systems, then Aerojet Rocketdyne. So these are different companies that are prime government contractors, or DoD contractors.
Sure.
And we do subcontracts for them in some of the programs,
Yeah, and it's pretty common to have a mixture of primes and subcontracts, and of course the big defense contractors. They subcontract to a lot of different businesses. Do you have any advice for a company that maybe they have their foot in the door, maybe they've won a SBIR, but they haven't subcontracted yet with a larger business? Maybe things to watch out for, and maybe some best practices.
I didn't get the question quite. So you're saying SBIRs are strictly for small businesses?
Right. What I was saying is some small business owners that are listening to the podcast may have their foot in the door. They may have a SBIR. Maybe they have a contract as a prime, but a lot of them are thinking about subcontracting with some of the big defense contractors, but haven't done it yet. And I was wondering if you had any best practices or cautions to somebody that hasn't approached that yet.
Well, the best way is just simply to reach out to them and, demonstrate what technology you have and then start discussing. But what SBIR does is a funding opportunity, so you can fund some of the research through this initial phase of work that nobody else wants to fund typically,
Right.
So you can take advantage of that and do a demonstrable solution. And ideally is, while going into phase 3, if you can connect through government to one of those prime contractors who are actually having service contracts for government for that kind of jobs, So let's say, taking an example, we are doing engine component, rocket engine component for government.
Right.
So there's already some of the contracts are given to these big prime contractors. So in phase 3, when you're going in, if you talk to your DoD partner and request them to connect with the actual prime contractor for that piece of business, they'll be happy to do that, because at the end, it's also their goal to transition this newly developed technology to a regular production channel for them. It's not just for the purpose of doing some R&D, right? So if you reach out to them, and that's what we have done, they have been extremely helping always to connect us with the prime contractors, and we all work together. Funding may come from government, DoD, but we all work together because it's great for them to see what's happening, and for government as well. To connect the prime contractors and the potential subcontractors,
Right. No, that's interesting. I don't think we've talked about that. Meaning using a government contact, maybe the program manager or contracting officer, engineer, someone you were working with on the government side or user through the SBIR program, and having them link you to a prime contractor or a larger defense company, which, as you're saying it, it's obvious to me. I'm thinking about all the times that, I would link companies together. Hey, we're working with Northrop on this one. We're working with,
Right.
Boeing or Lockheed on this other one, maybe, or BAE, like you're talking about. So, and making that connection for them, that is a good question, maybe to ask if you're in that position as a small business.
Yeah. Yeah, absolutely. I mean, I think like this is a win-win for everybody, right? I
Yeah.
mean, it's good for government, good for the prime, and good for the small business as well.
Yeah.
Because government typically does not order one piece of component, two pieces, and here and there. I mean, it's a whole engine they're going to buy. They're not going to buy components by itself. At the
Right.
end of the day,
Sure.
but so you have to work with whoever has the contract for the engine, if you want to go into that route and supply production parts.
That's a good point, because a lot of companies, when they first approach this, maybe aren't thinking along those lines, where, I mean, and it doesn't have to be something as sophisticated as building a rocket engine. It could just be someone who has a software or technology that is an API
Absolutely.
connector, or something to do with if human resources or user interface. The government typically buys the solution. They want to purchase if I was the government and I wanted a human resources solution, my solicitation probably wouldn't be for the company that does the API interfacing and kind of connecting everything. I want the total solution. So that company may have to partner with, you pick your company, your software business that has that solution, and they can integrate with them. And of course, sometimes there's subcontracting requirements for small businesses that the government puts out. So that's something else, I guess, to keep in mind.
Yeah, sure, absolutely.
Now, part of SBIR, typically on most SBIRs that I've seen, there's a requirement, or at least a government intent, that technologies have a dual application, dual use. Like, if you develop something in the SBIR program, a lot of the time, they not only allow but want you to be able to sell that commercially. Have you guys been able to take advantage of the commercial line of revenue I guess in association with some of the SBIR work you've done?
Yes, indeed. So again, going back to the space industry, because that's that's our biggest area. So whenever I talk, I will do multiple references of space. What we're doing with, for example, some of the development work with NASA. So these are all dual use technology. So you can use it for DoD, for maybe in the missiles area, but also in the commercial private space industry. So we do have private space customers, similar propulsion technologies. Of course, the designs are different. There are some differences here and there, but the base concept, once the technology is developed, I think you can use in dual use, and that's a big plus point in SBIR programs.
And you're in a really cool area too. That's really interesting. Are you, I mean, you're probably on a first name basis with Elon right now. Are you guys,
we do not do any work with SpaceX. I've been in their headquarters, but we do not. They are not one of our customers.
Okay,
they do most of the things in house. So they don't outsource a lot, as far as I know, anyway.
Yeah. I was just taking a shot in the dark there.
Yeah, but we do have other private space customers. Yeah.
Okay. Oh no, that's awesome. I mean, it sounds really, really interesting. What's next for you guys? What's on the horizon as far as government work, or maybe just where you think the company is going to be headed in the next 10 years?
What we are focusing on, Rick, is large metal part manufacturing. So typically additive manufacturing right now, the most accepted or adopted version is powder bed fusion, it's called. And people make parts that are about maybe 30, 40 inches in size. But what we are targeting with our technology, which is called like directed energy deposition technology, this is an ASTM category. So with this process and laser and powdered metal, we are targeting printing large metal parts. So we have printed some parts for NASA that are about 10 feet in size.
Oh, wow.
So you're printing a part that's taller than average human being and much taller. And these are like rocket engine nozzles. And so with this big part printing technology, we're trying to push the envelope of additive metal printing. So there are a lot of like space industry components that are very large, and currently, these are forged or cast. We have trouble here right now getting forging and casting. Some of the supply chains are affected because of the war in Europe, and so there's a lot of supply chain issues. So we're trying to fill in that area and produce some of this casting and forging replacements with our technology. Cut the lead time. Some of the programs we are working on, lead time is between 14 to 18 months, and we're targeting to cut it down to like 6-7 months.
Oh, wow.
So you have less than 50% lead time for some of these large parts. At the same time, we are cutting cost of manufacturing.
That's amazing.
So parts in the defense, Navy programs, some of the Navy programs, and there are multiple applications, but we're targeting more like large metal parts.
Sure. Yeah. Extremely interesting. And so let's pivot a little bit here. So that's where we're going. And by the way, I think most people, when I thought additive manufacturing, I was definitely thinking, small parts, right? And those are the, I've been through.
That's the most popular today. You're absolutely right. But our parts, if somebody goes to our website, DM3Dtech.com, you will see like a large RS-25 engine nozzle liner for NASA that we printed. So this is the engine which powered the Artemis mission for NASA, the space launch system. So this is like, when you see the space launch system, it's a tiny engine at the end, but that engine is about 14 feet tall, the whole engine, and the nozzle liner is 10 foot tall,
Oh, yeah.
So, it's a significantly large piece of metal there.
One of my bucket list items is to see one of these space launches in person. I haven't managed to do it yet, but I hear it's really interesting.
Neither did I. So like last year, I was in Johnson Space Center. So I was touring. I took actually my daughter. She was in a competition there, so they were hosting the competition. So I went in there and I just walk in, and then there's a model of RS-25 engine right there as you walk in, and I show my daughter, and this is the part we are printing here at DM3D.
Oh.
You should see this
awesome.
picture. So yeah, she was very excited seeing this. Me was more excited than her. I was.
Oh, I bet. It sounds like she might be taking on the family business here. Is she headed to be an engineer or maybe an astronaut or something?
She might go into engineering, but she is doing actually chemistry, so in college. So
okay, I showed you my ignorance to the different engineering fields, and I got schooled a little bit when I. About halfway through my Air Force career, I switched from flying to acquisitions. So now I had an engineering team that was working with me, and my chief of engineer, I made a comment about. I basically was saying all the engineers were, kind of the same or had the same education. He's like, no, Rick, no. He goes, there is a pecking order of engineers. And at the bottom you have, I believe he said civil engineers in his mind were kind of at the bottom of the list. But he had chemical engineers way at the top of that list, I remember. And it was a fun little competition among all the engineers to kind of claim who was the smartest or had the best career.
Right, yeah.
You mentioned your website, DM3Dtech.com, for the audience. If they want to reach out to you, is that the best place to go if they're small businesses or somebody interested in your technology on the government side?
Absolutely, yeah. There's email address and phone number, so they can reach out directly there through that to us, and we'll get right back to it.
Perfect. All right. Well, you guys heard it here first. So we'll put the address, the website in the show notes, so anyone can go in there and click on them if you're listening to this. Bhaskar, thank you for coming on the show today. This has been an awesome conversation. Probably one of the most interesting companies that we've talked to, especially considering how deeply you're involved with the space industry.
Thank you, Rick. I really appreciate this opportunity to talk to you, and all the best for your program.
Well, thanks again. All right, everyone. Thanks for tuning into this week's episode of DoD Contract Academy with DM3D. If you want to learn more about selling to the U.S. government, head on over to dodcontract.com, where you can check out our academy, our blog page, and see some of our free training. And until the next episode, we'll see you next time.